Hello 8th graders, this is teacher Monique and we will learn how to factor the different types of polynomials. This time, we will learn how to factor sum and difference of two cubes. To fully understand the topic, let us recall first what is a perfect cube. Perfect cubes are numbers or expressions that can be expressed to the power of 3. So let us have this exercise. Let us determine whether the given expressions are perfect cube or not. And we are going to express that in an exponential form with a power of 3. Number 1 is 27. So how are we going to determine whether 27 is a perfect cube or not? Think of a number that if we are going to multiply 3 times by itself, the result is 27. That number is 3. So 27, the cube root of that is 3. Because if we are going to multiply 3 times by itself, the result is 27. So if we are going to express that in an exponential form, the cube root 3 will be raised to the power of 3. So we have quantity of 3 raised to the power of 3 is the exponential form. Therefore, 27 is a perfect cube. Next, we have 8. Think of a number that if we're going to multiply 3 times by itself, the result is 8. That number is 2. Therefore, 2 is the cube root of 8. Because if we are going to multiply 2 3 times by itself, the result is 8. And if we are going to express that in an exponential form, the cube root 2 will be raised to the power of 3. So we have there, quantity of 2 raised to the power of 3 is the exponential form of 8. Therefore, 8 is a perfect cube. Next, we have 64y cubed. This time, we have a numerical coefficient and a literal coefficient. So therefore, we have to consider that 2, meaning our literal coefficient and our numerical coefficient must also be a perfect cube. So think of a number or expressions that if we're going to multiply 3 times by itself, the result is 64y cubed. So that expression is 4y. Because if we are going to multiply 4y 3 times by itself, the result is 64y cubed. 4y is the cube root of 64y cubed. So if we are going to express that in an exponential form, that will be quantity of 4y raised to the power of 3. Therefore, 64y cubed is a perfect cube. Next, we have 125x cubed. So, we are going to consider the numerical and the literal coefficients. They should be a perfect cube in order to find the cube root. So in this case, 125 is a perfect cube and x cubed is also a perfect cube. So the cube root of 125 cube at 125x cubed is 5x. Because if we are going to multiply 5x 3 times by itself, the result is 125x cubed. So if we are going to express that in an exponential form, the cube root 5x will be raised to the power of 3. So we have quantity of 5x raised to the power of 3. Therefore, 125x cubed is a perfect cube. Next, we have 27x to the 6th power, y to the 12th power. So, we have there the numerical coefficient, which is 27, is a perfect cube. The variable x, or the literal coefficient x to the 6th power, is also a perfect cube. And y to the 12th power is also a perfect cube. So the cube root of that is 3x squared y to the 4th power. And if you're going to multiply that 3 times by itself, the result is 27x squared y to the 12th power. So if we are going to express this in an exponential form, the cube root, which is 3x squared y to the 4th, will be raised to the power of 3. Therefore, this is a perfect cube. Now, in factoring the sum and difference of two cubes, we have to follow these steps. So we have here the sum, or the steps in factoring the sum and difference of two cubes. First, we are going to determine whether the given polynomial is a sum or difference of two cubes. So if the sum of two cubes, if the polynomial is a sum of two cubes, we are going to get the roots of the first and the last terms and write their sum as the first factor. So the pattern of our first factor will be quantity of A plus B. Next step is getting the second factor. So for the second factor, we are going to get the trinomial factor by A squaring the first term. So our first term is A. We're going to square that one. That will become A squared. Step B, subtracting the product of the first term and second terms of the first factor. So we have here our first factor. We are going to subtract the product of the first and the second term. So meaning we are going to get first the product of the first and the second term. So A times B will become AB. And we are going to subtract that product in order to get the second term. So we have minus AB. Third step is we are going to square the last term of the first factor. So the last term of our first factor is B. So we are going to square that one, and that is B squared. So this is our second factor. So after that, step 4, we are going to write them in factored form. So the factored form will look like this. So the pattern is quantity of A plus B, the first factor, and quantity of A squared minus AB plus B squared, which is our second factor. Now, what if the given polynomial is a difference of two cubes? So we have here the steps. If difference of two cubes, we are going to get the roots of the first and last terms and write their difference as the first factor. So the pattern of our first factor will be quantity of A minus B. Next step, getting the second factor. So we're going to get the trinomial factor by A squaring the first term of the first factor. The first term of our first factor is A. So we're going to square A, that is A squared. Next, we're going to add the product of the first and second terms of the first factor. So our first factor is A minus B. We're going to multiply or get the product of the first term and the second term. So A times B will become AB, and we're going to add that in order to get the second factor or the second term. Next, we have squaring the last term of the first factor. The last term here of our first factor is B. So we are going to square that. That will become B squared. So this will now be our second factor. So last step, we are going to write them in factored form. So the factored form will follow the pattern quantity of A minus B, our first factor, times the quantity of A squared plus AB plus B squared, which is our second factor. Now, the question is, when do we say that the given expression is a sum of two cubes or a difference of two cubes? If the given polynomial has this pattern, A cubed plus B cubed, so this is sum of two cubes. So if we are going to factor sum of two cubes, the pattern of its factors are quantity of A plus B times the quantity of A squared minus AB plus B squared. And if our polynomial looks like this or has a pattern like this, A cubed minus B squared, that is difference of two cubes. So in factoring the difference of two cubes, the pattern of our factors are quantity of A minus B times the quantity of A squared plus AB plus B squared. Now let us have example number 1. Factor y cubed minus 27. First, we're going to determine whether the given polynomial is a sum or difference of two cubes. Since it is a difference of two cubes, the pattern of its factors will look like this. So what we're going to do? Get the roots of the first and last terms. Our first term is y cubed, and the cube root of that is y. Our last term is 27, and the root of that is 3. So we have here our first factor, quantity of y minus 3. Next step, we have getting the second factor. So to get the trinomial factor, we are going to square the first term of the first factor. So if this is our first factor, we are going to find the square of the first term, and that is y squared. In order to get the second term, we are going to add the product of the first and the second term of the first factor. So meaning to say, we are going to add the product of the first and the second factor. We are going to multiply y times 3. and that will give us 3y. Then for the last term, in order to get the last term of the second factor, we are going to square the last term of the first factor. The last term of our first factor is 3. Therefore, we're going to square that, and that is 3 squared. So this is our second factor. Last step, we are going to write them in factored form. So the factored form of our first and the second factors will be the quantity of y minus 3 times the quantity of y squared plus 3y plus 3 cubed, or 3 squared. So we have here, if we're going to factor y cubed minus 27, the complete factors are quantity of y minus 3 times quantity of y squared plus 3y plus 3 squared. Now let us have example number 2. Factor 8m cubed plus 125. Since this is a perfect cube, the next thing that we're going to do is to determine whether the given polynomial is a sum or difference of two cubes. Now, since we have here the plus symbol that separates the two terms, meaning this is a sum of two cubes. So in order to get for the first factor, we are going to get the roots of the first and the last terms. So we have the first term is 8m cubed, and the root of that is 2m. And then the last term is 125, and the cube of that is 5. So we are going to write that as a sum of the first factor. So we have here 2m plus 5 is our first factor. Next is we are going to find the second factor. How are we going to get the trinomial factor? That is, we are going to square the first term of the first factor. This is our first factor, and the first term is 2m. So we are going to square 2m. That will be 4m squared. In order to get the second term, we are going to subtract the product of the first and the second terms of the first factor. So this is our first factor. We are going to multiply in order to get the product. Multiply the first term 2m by the second term 5, and that will become 10m. Then third step in getting the second factor is we are going to square the last term of the first factor. So the first factor, we are going to square the last term, which is 5, and that is 25. So this will now be our second factor. Next step, we are going to write them in factored form. So meaning to say, the first factor is the quantity of 2m plus 5, and the second factor is quantity of 4m squared minus 10m plus 25. So if we are going to give the complete factor of 8m cubed plus 125, that is equal to the quantity of 2m plus 5 times the quantity of 4m squared minus 10m plus 25. This time we're going to have an activity complete me, meaning to say you're going to fill in the missing terms. Number 1, factor 27x cubed minus 64y cubed. In the first factor, the missing term is the first term. In order to get the first term of the first factor, get the cube root of the first term of the given polynomial. So the cube root of 27x cubed is 3x. In the second factor, the missing term is the second and the last term. In order to get the second term of the second factor, get the product of the first and the last term of the first factor. So 3x times 4y, the product is 12xy. In order to get for the last term of the second factor, square the last term of the first factor. So if we are going to square 4y, that will give us 16y squared. Therefore, the complete factor of 27x cubed minus 64y cubed are quantity of 3x minus 4y times quantity of 9x squared plus 12xy plus 16y squared. Number 2, factor 8 plus b cubed. In the first factor, the missing term is the second term. To get the second term of the first factor, get the cube root of the second term of the given polynomial. So the cube root of b cubed is b. In the second factor, the missing terms are the first term and the last term. To get the first term of the second factor, get the square of the first term of the first factor. So the square of 2 is 4. In order to get for the last term of the second factor, get the square of the second term of the first factor. So we have b squared. Therefore, the complete factored form of 8 plus b cubed are quantity of 2 plus b times quantity of 4 minus 2b plus b squared. Number 3, factor 8h to the 6th power plus 27k to the 6th power. So, all the terms of all the factors are missing. To find the first term of the first factor, get the cube root of the first term of the given polynomial. So the cube root of 8h to the 6th power is 2h to the 2nd power. To get the second term of the first factor, get the cube root of the last term of the first or the given polynomial. So the cube root of 27k to the 6th power is 3k to the 2nd power. Next, we have the second factor. To get the first term of the second factor, get the square of the first term of the first factor. So the square of 2h to the 2nd power is 4h to the 4th power. To get the second term of the second factor, get the product of the first and the second term of the first factor. So 2h to the 2nd power times 3k to the 2nd power, that will give us 6h squared k squared. And to get the last term of the second factor, get the square of the last term of the first factor. So the square of 3k squared is 9k to the 4th power. Okay, this time, let us see whether the given factors in the previous activity are correct or not. For number 1, the complete factors of 27x cubed minus 64y cubed are the quantity of 3x minus 4y times quantity of 9x squared plus 12xy plus 16y squared. So how are we going to check? We are going to multiply the first term of the first factor by each term of the second factor and multiply the last term of the first factor by each term of the second factor. So we have 3 times 9x squared, we have 27x cubed. 3 times 12xy will give us 36xy, x squared y. The symbol that we're going to use is plus. Next is 3 times 16y squared. That will give us 48xy squared. Again, the symbol is plus. Next is, we are going to multiply the last term of the first factor by each term again of the second factor. So let's continue. 4y times 9x squared, that will give us 36x squared y. So minus because we have here unlike sign. Next we have 4y times 12xy. That will give us 48xy squared. Again, minus here because we have here unlike sign. And last we have 4y times 16y squared. That will give us 64y cubed. Still unlike sign, so we have minus. Then after that, examine the partial answer. Now we are going to combine the like terms. So examine if there are like terms, and if there are, we're going to combine like terms. Since we only have 1 in the power of 3, so we have 27x cubed. We're going to arrange para madali makita. So we have 36x squared y. The like terms are or is 36x squared y. So these are like terms. Next we have plus 48xy squared. Like terms we have here 48xy squared. They have the same literal coefficients, therefore they are like terms. And last term, wala na siyang kasama, so we have 64y cubed. So we are going to combine the like terms. So we have here, like terms are positive or plus 36x squared y minus 36x squared y. So we are going to combine. That will give us 0. Another one, we have plus 48xy squared minus 48xy squared. So if we're going to combine, that will give us 0. So we have the remaining terms, 27x cubed minus 64y cubed. So if the remaining term will be the same or is the same with a given polynomial, the factors that we have is correct. Okay, next, for number 2, factor a plus b cubed. So our answer is quantity of 2 plus b times quantity of 4 minus 2b plus b squared. In order to check whether these factors are correct or not, we are going to multiply. Again, multiply the first term of the first factor by each term of the second factor, and multiply the last term of the first factor by each term of the second factor. So we have 2 times 4, we have 8. Next, minus, so 2 times 2b, that will give us minus 4b, plus, so plus and symbol, so we have 2 times b squared is 2b squared. Next, second term of the first factor. So b times 4, that will give us 4b plus 4b. Next, we have b times negative 2b, so that will give us negative 2b squared. And b times b squared, that will give us positive b cubed. Next, we're going to arrange so that we can determine easily if there are like terms. So you have 8, negative 4b, then we have plus 4b, plus 2b squared, minus 2b squared, plus b cubed. So here we have like terms. So we are going to combine the like terms. We have minus 4b plus b, unlike signs, so that will, if we're going to subtract, that will give us 0. So we have here plus 2b squared and minus 2b squared, that will give us 0. So the remaining terms are 8 plus b cubed. So it shows that the remaining terms here is the same with the given polynomial. Therefore, our product or our factors here is correct. So for number 3, factor 8h to the 6th power plus 27k to the 6th power, the given factors are quantity of 2h squared plus 3k squared times the quantity of 4h to the 4th power minus 6h squared k squared plus 9k to the 4th power. So in order to check, we're going to multiply these two factors. So again, multiply each term of the first factor by each term of the second factor. So we have 2h squared times 4h to the 4th power. That will give us 8h to the 6th power. Next, 2h to the 2nd power times negative 6h squared k squared, that will give us minus 12h to the 4th power k squared. Then we have 2h squared times 9k to the 4th power. All positive, so we have plus 18h squared k to the 4th power. Next, second term or last term of the first factor by each term again of the second factor. So we have 3k squared times 4h to the 4th power will give us 12h to the 4th power k squared. Next, we have positive 3k squared times negative 6h squared k squared. That will give us negative 18h squared k to the fourth power. Next, we have positive 3k squared plus 9k to the fourth power. That will give us positive 27k to the sixth power. Next, arrange in order to find easily if there are like terms. So we have 8h to the sixth power minus 12h to the fourth power k squared plus like term. We have 12h to the fourth power k squared. Next, we have plus 8 squared k to the fourth power. Then the like term of that, we have minus 8h squared k to the fourth power. And the last term is 27k to the sixth power. Then we are going to combine the like terms. So we have, if we're going to combine these two like terms here, the result is 0. Another two like terms here, the result is 0 because they are unlike sign. So meaning the remaining terms are 8h to the sixth power plus 27k to the sixth power. So if the result is the same with the given polynomial, then the factors that we have achieved is correct. So that's all for this lesson. See you next time.